Hi, so this is number 8. And so this one gives us 4 different situations, and they're all exponential growth kind of situations. So for each of them, we are supposed to do these 4 things. We're supposed to find the multiplier in the situation, the initial value, which is the same thing as starting value, and then we're supposed to write an exponential equation for each situation. And then we also need to write let statements telling what X and Y represent in that situation. So for this first one, for A, it says a house is purchased for $120,000 and then it has an annual appreciation of 6%. So appreciation is the opposite of depreciation. With appreciation, it's actually gaining value. It's becoming more valuable each year by 6%. So for the multiplier, if something is going up in value by 6%, we want to add that to 100% because it already has 100% of its value and then it's gaining another 6%. So that's 106%. If we divide that by 100 to convert it to a decimal, we get 1.06. So our multiplier for this one is 1.06. Initial value is just the starting value of the house. So that was the $120,000. So then we're going to go ahead and write our equation. So we're going to have f of x equals, and then we know it's going to look like this. A times b to the x. A is the starting value, which was the 120,000. And then b is the multiplier, which was 1.06. And then that's to the x power. So that's our equation. And then last thing we have to do for this one is say what x and y represent. That's what our let statements are. And really, if we're going to say y here, we should probably have put y here instead of f of x, but that's okay. So we're going to say let x equal. So x in this one is how much time has gone by. Like it's how many times the house has gained that 6%. And it says it's annual. Annual means once a year. So x would be the number of years that have gone by since the house was purchased. So the number of years that they've owned that house. And then we need to say what y represents. So for y is what we get when we plug in numbers. So what we get is the value of the home. So that is what y represents. Y is the value of that house, how much it is worth. So for B, we're going to go through the same process. So for this one, it says the number of bacteria present in a colony is 180 at noon. So that's what it started out at. So I'm going to go ahead and put 180 as the initial value. So noon is like our starting time. And then it increases, so it goes up at 22% per hour. So again, because it's increasing by 22%, we're going to add that to 100. That's 122%. And then to convert to a decimal, we're going to divide by 100 because percentages are always out of 100. So that's 1.22 would be our multiplier. So our equation is going to be y equals starting value times multiplier to the x power. So that's our equation for this one. So in this one, it says it increases at a rate of 22% per hour. So x would be the number of hours. And since it started at noon, we're going to say the number of hours since noon. And then y is what the function is telling us, which is how many bacteria are there. So y is the number of bacteria in the colony. So those are our let statements saying what x and y represent. So for C, it says the value of a car with an initial purchase price of $12,250. So that's our initial or starting value is $12,250. Now this car depreciates, meaning it loses value by 11% per year. So for this one, we're going to do 100% minus 11% because it's losing 11%. So 100 minus 11, that's 89%. Dividing by 100, our multiplier is 0.89. And it's less than 1. That way when we multiply that, the number will actually go down because it's depreciating. So our equation is y equals our starting value times our multiplier to the x power. and then what x is representing. So it depreciates by 11% per year. So x would be number of years since the car was purchased. And then y would be the value of the car, because that's what this function tells us. So x is years since car was purchased. Y is the value of the car. And then finally, for part D, it says a farm begins with 18 bunnies. So initially, there are 18. That's our starting value. And then the number of bunnies triples each month. So this one is not a percentage. This is just saying it triples. Triples means multiplies by 3. So this one, the multiplier, we don't want to think too hard about it. It's just 3 because the number of bunnies is always being multiplied by 3 each month. So our equation is y equals 18, which was our starting value, times our multiplier of 3 to the x power. If it said doubles, we would have 2 be our multiplier, but tripling means multiplying by 3. And then for x, so it triples each month. That would mean, so x is how many times it's tripled. So x would be the number of months that have gone by since they started off with the 18 bunnies. And then y is what the function tells us, which is the number of bunnies on the farm.